In this example, we are going to apply the definition of limit to show that the limit of the function iz over 2 is equal to I over 2 as z approaches 1. We recall that from the definition we see that a complex function f of z has a limit w0 as z approaches z0. If for every epsilon greater than 0 there exists a delta greater than 0 such that the absolute value of f of z minus w0 is less than epsilon whenever z satisfies this condition. Now, according to the definition, the given limit will be true if for every epsilon greater than 0 there exists a delta greater than 0 such that the absolute value of iz over 2 minus I over 2 is less than epsilon whenever z satisfies this condition, that is, the absolute value of z minus 1 is larger than 0 and less than delta. Now we need to find delta in terms of epsilon. Now we will simplify the left part of the inequality 2 in this way. We know that absolute value of z1, z2 is equals this. So we apply this formula here and get this one. And also we know that since absolute value of I is 1 and absolute value of 2 is 2. So finally we are getting this. Now equation 2 gives this one. Now for a given epsilon greater than 0, we define delta equals to epsilon so that for all z satisfying this inequality. So equation 3 gives half times absolute value of z minus 1 is less than half into delta, and we replace delta equals to epsilon and finally we get epsilon. So from here we see that absolute value of iz over 2 minus I2 is less than epsilon. And this concludes the proof. This one is another example of limit which also requires the use of definition. According to epsilon delta definition, this limit will be true if for every epsilon greater than 0 there exists a delta greater than 0 such that this inequality will be true whenever this one is true. Now we need to find delta in terms of epsilon. Now we will simplify the inequality 2 as we did in the previous example. We take 2 plus I as a common factor and then apply this law, which one we applied in our previous example also. and simplify these two terms. We know the law from modulus. This is square root of 5, and for this one we apply the quotient law. As we know that we have to multiply both the numerator and denominator by the conjugate of denominator. So after simplification we get this inequality. Now for a given epsilon greater than 0, we will define delta in this way, so that for all z satisfying this inequality, and then inequality 3 gives this one. Here we replace delta by epsilon over square root of 5, and these two will be cancelled, and finally we get epsilon. So this is the required one, and which shows that the given limit in the question is true.